Welcome to The Explainer. Today, we're diving into what we call the shape party, a really vibrant look at the literal foundational building blocks of our physical world. We're looking at the exact geometry making up everything around us, translated into this fun room filled with floating balloons, sturdy blocks, and twinkling stars. Let's break down these core structures one by one.
So it kind of begs the question, are you ready for a fun, magical adventure? Are we ready to actually notice the geometry hiding right in plain sight? Because honestly, once you start looking, you realize shapes are absolutely everywhere. We've got an exclusive red carpet guest list of geometric figures today, and we're going to break down exactly how they work.
Section 1, Round and Rolling Shapes. Guests with zero sides. Our very first guest rolling into the party is the circle. Now, a circle is a shape that's completely round, with absolutely no sides. And that lack of sides, that's exactly what allows it to effortlessly go round and round, rolling across the floor just like a ball. The crucial point here is the number 0. A circle has exactly 0 sides and 0 corners. Actually, this specific geometric lack of edges is literally what allows it to roll endlessly. Without any corners to stop its momentum, the circle is perfectly designed for continuous motion. It's brilliant, really. To really grasp this, we can look to the party's resident expert, the blue mouse, who excitedly points out, "A circle! Just like my favorite yummy cookie!" I love this because it brilliantly grounds the abstract concept of a zero-sided shape into something highly recognizable and delicious in our everyday lives. Let's feel out the mechanics here. Put your finger in the air, now spin it round and round and round. By spinning this continuous, unbroken line, you can physically visualize exactly why a circle has no starting point and no end. It just keeps going. Okay, next up is the oval. The oval takes that foundational concept of the circle, but it alters it slightly. It's a smooth, curvy shape that kind of looks like a stretched-out circle. Putting them side by side really highlights the core difference. On one hand, you've got perfectly round, that's our circle, uniform in every direction. On the other hand, you've got stretched out, that's the oval. It shares that exact same zero-edge property, but its proportions are elongated. And our friend the mouse notes exactly where we see these stretched-out shapes in the real world, squeaking out, an oval, just like a funny little egg or a shiny balloon. This perfectly highlights the oval's stretchy nature, which shows up all the time in organic forms or flexible objects. Let's try this one out physically. Stand up, now stretch your arms out wide like a big oval balloon. That wide, elongated tension you feel? That's the exact geometric property that separates our stretched oval from our perfectly round circle.
Section 2. The pointy guest. Adding sides and corners.
So, next up is the triangle. And this is a game changer because instead of endless curves, the triangle introduces hard boundaries. Specifically, it's a pointy shape with exactly 3 sides and exactly 3 corners. We really have to emphasize the number 3 here. 3 is the absolute magic number for this pointy guest. You count 1, 2, 3 sides, and 1, 2, 3 corners. If it doesn't have exactly 3, well, it simply isn't a triangle. The mouse is back to remind us where we've seen this in the wild, cheering, "Whee!" It's pointy like a yummy slice of pizza. And it's so true. It's a shape that naturally draws the eye to its sharp, distinct points. Think of things like fun party hats or, pizza. Let's make one. Touch your 2 pointer fingers together at the top, and then make a slide down. Boom! By tracing 2 lines up to a peak and 1 across the bottom, you just created 3 distinct sides and corners. You built a triangle right out of thin air.
Section 3. The four-sided friends. Squares and rectangles.
Enter the square. This is a super strong shape featuring 4 sides and 4 corners. But, and this is a big but, here's the critical rule for this specific guest. All 4 of those sides must be the exact same size. So the number 4 takes center stage here. But remember, it's not just about having 4 sides. It's about having 4 identical, perfectly matched sides. As the mouse points out by holding up a tiny square block, this perfect equality is exactly what makes the square such a fantastic, sturdy building block.
To map out this strong shape, take your finger again. Go down, go across, go up, and close. 4 equal sides perfectly enclosing the space. You just engineered a perfect square.
Next, sliding into the party is the rectangle. Now the rectangle shares a ton of DNA with the square. It's a shape with 4 sides and 4 corners too. However, it breaks that golden rule of equality. In a rectangle, two sides are distinctly long and two sides are distinctly short.
The structural relationship here is super clear when you compare them. Four sides of the exact same size, that's your square. Two long sides and two short sides, that's your rectangle. The rectangle essentially takes the square's structure and just pulls it. They're geometrically related, for sure, but fundamentally different in their proportions.
The mouse demonstrates this perfectly by throwing open a door for us. A rectangle, just like a door or a cool smartphone. It's kind of wild when you realize that things like books, doors, and the phones we literally stare at every single day completely rely on this exact long and short-sided geometry to function.
So looking at our complete guest list, the real-world shape dance, if you will, we've got cookies, eggs, balloons, pizza, party hats, building blocks, doors, smartphones, and books. We see these foundational geometries hiding everywhere. They aren't just abstract ideas. They are literally the blueprints of our physical world.
Before we wrap up this explainer, I want to leave you with one final thought. What secret shapes are hiding in your room right now? Seriously, take a look around. Which of these foundational rules are holding up your ceiling, your screen, or your furniture? Once you understand the basic geometry of the shape party, you realize you're always surrounded by it. Keep exploring, and I'll see you on the next explainer.